Hello students, today we are going to discuss one more problem from solid state physics. This question came in IIT-JAM 2019 exam, the question number 42 and with a subsection of crystallography. Okay, so in this question, the question is saying that sodium exhibit BCC structure whose radius is given 0.186 nanometer and we have to find the lattice parameter small a. Okay, so basically we have to get the relationship between radius small r and lattice parameter a. So for that I have made a BCC structure here, okay, whose side is small a. First of all, we need to understand the thing that if we have to get the relationship between radius and lattice parameter, for that we have to first find out the nearest neighbor distance. And after that, we can get the radius of that atom. Okay. So first of all, what we will do, we will find the nearest neighbor distance. So for that, I have chosen a reference atom. Okay. Now, let's say as a sphere. Okay. So now I will abbreviate this as a sphere. So this is our reference sphere. Okay. So for the nearest neighbor distance, we have to find, we need to look that which another sphere are nearer to this sphere. Okay. See, one sphere is this, which is at a distance A. Another sphere is this sphere at a phase diagonal. What will be the distance of this sphere to this reference sphere? This will be root 2a. How will you find? This is A, this is A. So from the Pythagoras, what will be this distance? This will be a square plus a square, and that will be a root 2. Okay, so what will be this distance? This will be a root 2. Okay, now if we have to take distance from this reference sphere to, let's suppose, this sphere, okay, which is at the body diagonal. So what will be this distance? What will be this distance? If this distance is a root 2, this distance we know this is a. So what will be this distance? This will be under root of a square plus 2a square. So this distance will be a root 3. So the distance from this sphere to the body diagonal, what will be this? This will be a root 3. Okay. So we have got three distances from this reference sphere. One toward with respect to this sphere, one towards this, and one towards this. Okay. If we want to take the distance from this reference sphere to this sphere, which is present at the body center, what will be this distance? If this complete distance is a root 3, then what will be this distance? This will be half of the body diagonal distance. So that this distance will be a root 3 divided by 2. Okay. So it's a very easy from here to get the nearest neighbor. See, one sphere at the distance a, this sphere at the distance a root 2, this body diagonal sphere at the distance a root 3, and this body centered sphere at the distance a root 3 by 2. Which is shorter? It's very simple. Which is shorter? A root 2, a root 3, or a root 3 by 2? This is shorter, no? Okay, so if this distance is shorter, that means this, the body centered sphere, will be very close to this reference sphere. So that means this is our nearest neighbor, and this distance, that is a root 3 by 2, will be our nearest neighbor distance. A root 3 by 2 will be our nearest neighbor distance. Okay, so now after getting this, what we have to do, just forget all these things. Okay, but just see these two sphere only. Okay, just focus on these two sphere. One is reference sphere, let's suppose it is here, and this body center was here. Okay, if we make a big sphere considering these two at the center, let's do. If we considering this as a center, we are making a sphere, and the same considering this as a center, I'm also making it again a sphere. Okay, this is a sphere whose radius is smaller, let's suppose. So this radius will be also smaller. Okay, and what will be this distance? This complete distance we have found is the nearest neighbor distance. So this distance will be a root 3 by 2. Okay, so r plus r, that is r plus r, that is how it will be equal to how much? A root 3 by 2. That is, from here r will be equal to a root 3 by 4. So this is our final relation between the radius r and lattice parameter a. Okay, this will be our relationship. Now, value of r is given, and it's been asked that we have to find the value of lattice parameter. So from here, we can easily get the value of a will be how much? 4 by under root 3 of r. Okay, the value of r in the question is given as 0.186 nanometer. If you will solve this, you will get approximately 0.43 nanometer. So this will be our value of lattice parameter. Okay, thank you.